So my suggestion for each of these first 5 is to begin by identifying our values for A, H, and K. So for number 1, hopefully you can see that A is 1, H is 0, and K is 6. So the only value we have to worry about is the K. Everybody agree with that?
Yeah.
So if I write my 1, 2, 3, 4, the only thing that's happening is 4, and we're going up 6 units. So remember how we listed those 4 criteria in the notes? So this list right here. So again, I'm just going to, for shorthand purposes, refer to this as like 1, 2, 3, 4. So the 4th thing is about the K. Okay. So just so that we're all on the same page with kind of what we're talking about. So when I talk about 1, 2, 3, 4 with regard to transformations, I'm talking about these 4 rules. Okay? Cool. Good question. For 2, we see that A is 3, H is 2, and K is 0. So since the A is positive, we only have to worry about part 2. So since the absolute value of A is greater than 1, we can have a vertical stretch. 3 does something because the H is non-zero. Since the H is positive, it'll be right. And 4 doesn't do anything because K is 0. On the next one, we have A is -3. I'm sorry, A is -1, H is -3, and K is -6. So since the A is negative, we have a reflection across the x-axis. But since the absolute value of A is 1, there's no second. For 3, this happens because the H is negative, we go left. And since the H is -3, we go 3 units left. And for 4, since the K is negative, we go down. And since the K is -6, it's down 6. Everybody so far so good? Alexis. So remember that the general form has a subtraction symbol there. So if I plug like -3 in for H, I'd have x minus a -3 or x plus 3. So the H's are always going to be kind of the opposite sign that they appear in the equation. So notice on number 2, the H is +2 even though it's x minus 2. Okay with that? Next up, so here A is 1/2, H is -3, K is 0. So since the H is positive, since the A is positive, step 1, we don't do anything. Step 2, since the absolute value of A is less than 1, we have a vertical shrink. And since the H is negative, we're going to go left. And since it's -3, we'll go 3 units. And then nothing happens for 4 because the K is 0. And then our last one, so the A is negative, so we have that reflection across the x. The absolute value of A is not 1. In this case, since the absolute value of A is greater than 1, we have a vertical stretch. since the h is non-zero, we have a translation. Since the h is positive, we're going to go right, 9, and then since the k is non-zero, we have a translation up and down. Since k is positive, we go up. In this case, 1. Is everybody okay with that part? Any questions on what I did there? For the most part, did I have to do any calculation here? No, I'm just like reading the values and using those rules that we had set up in the last class to describe that in words. So, should be relatively easy, provided that you remember those values. Okay. So, for 6, 7, 8, 9, and 10, we're going to be drawing a transformation of this graph. The first thing I'm going to do is I'm going to identify the values for A, H, and K for each of these. Correct. Yes. Yeah, there's always an answer to all of these A, H, and K's. 0 or 1, yeah. So they could be, if it's not there, or 1. Like in the case of the A. Correct. Yep, absolutely. So what I'm going to do then is I'm going to use that transformation map idea to transform the coordinates for each of these problems. So I'm going to copy down the points that are given to me in the graph. So I have negative 1, 0, negative 0.15, negative 3.08, 1, 0, and then 215, 308, and then the last one is 3, 0. So for number 6, what I have here is x plus 0, 1 times y plus 1 is the rule that I'm doing. Everybody okay with that? So I just filled in my values for A, H, and K. So I have negative 1, 1, negative 0.5, negative 2.0, 8, 1, 1, 215, 4.08, and 3, 1. And then I can just plot those points and connect them. Is it okay if I skip plotting the points and connecting them? So we're okay plotting points and drawing in the graph. So if I'm going to look at 7 then, I have x plus h, comma, a times y plus k So I have 1, 0. I have 1.85, comma, negative 312. And I have 3, 0. And then I have 415. And then, oh my goodness, I don't mean 312 here. I meant 462. I accidentally typed 2.08 in my calculator instead of 3.08. Mr. Gulick, you're so silly. And you just boogered that one up. You know? Sometimes you just make a booger of stuff. Yes, sir.
I understood when you filled this part. Like, what are you doing right now?
7.
Yeah, I know the number. I'm just saying, like, what are you doing once you got all the A's and the...
So I'm plugging in the original ordered pair, the ones from the graph that I wrote down there on the left-hand side. I'm just plugging those x's and y's into that formula.
So we should probably know what x to put. What's the formula?
This is the formula I used.
Oh, and then you just reswap?
Yeah, and I'm just plotting my next set of 7. So remember, this we gave you guys at the end of yesterday, this transformation map at the end of last lesson, right? And I showed you doing the exact same thing instead of like doing these transformations one at a time. I can do them all at once to save myself a lot of work, and that's all I'm doing here. Okay? So again, I'm taking the 5 pairs of points that were given to me in my original graph and applying this transformation for each of the separate problems to get my new points that I would draw the graph for to get the desired transformed graph.
Okay.
Does that feel okay?
Yeah, so you do this thing to all of the points. So
Yep. So every point from the original, I plug into my little formula that I make for each of the 5 separate problems, 6 through 10. And then that's going to give me a new set of points, which I could plot to get the transformed graph. Okay with that? Okay. So if I do 8 then, so here my h is negative 3, my a is negative 1, and my k is negative 2. So if I go ahead and I plug negative 1, 0 in for x and y, I get negative 4, negative 2. If I plug negative 0.15, comma negative 3.08 in, I get negative 315, comma positive 1.08. If I plug 1, 0 in, I have 1 minus 3, that's going to give me negative 2, negative 0 minus 2, which is just negative 2. If I plug the 215, 3.08 in, 215 minus 3 is negative 0.85. And 308 negative is negative 308 minus 2 more is negative 508. And then similarly I have 3 minus 3 and then 0 minus 2. Everybody okay there? Here, so for 9, we have is x minus 4, and then 1/2 y plus 0. Okay. So I'm going to have -5, 0, and then -415, and then half of 305 is -1.54, and then -3, and then -1.85, comma, positive 1.54, and then -1, 0. Okay with that? And again, I'm going to skip drawing the graphs on these, as you guys said you felt pretty good about plotting points and drawing the graphs. So just in the interest of time and in neatness, certainly getting all 5 of these on the same graph was going to be kind of a nightmare. So I'm just going to skip that part. All right, and then for 10, we're told that my h is 1, my a is -3/2, and then my k is 2. So if I plug -1, 0 in, I get 0, 2. If I plug in -0.15, comma, -3.08, I have positive 0.85, comma, $6.62 here. God bless you. You're welcome. When I plug in 1, 0, I get 2, 2. And when I plug in 215, 3.08, I have 3.125, comma, and that's 460, so -262. What's up? I wrote down the right thing. If I said the wrong, I apologize on that. Sometimes you get writing and you're writing one number and you say a different number. Ever happened to you? Yeah, I just did it, apparently. And then the last one is 0, 2. Nope, the last one is 4, 2. Goodness gracious. Any final questions on this transformation sheet? Okay. For the review, I want to point out one thing kind of before we get started here, is that if we go to our PowerSchool page, and we look at the review on the calendar, and we click on that assignment, and we have to log back in because apparently PowerSchool timed me out while I was at lunch. And we log back in, you'll see that this morning I've added another attachment to this assignment, that being the key. So you can see the solutions there. Now we'll certainly talk about things still here in class. I plan on taking time and going through things, as many as you want to do in the time we have. But anything we don't get to, you can check the correct answers from this assignment on PowerSchool. So if you go back and find the assignment, The key is now there for you to check at your leisure. Everybody feel okay with that? And you know where to go to find this? Yes, of course. Okay. Would you prefer to go in order or jump around? Okay, that's fine. So on number 1, it says give an example of a relation that's not a function and a relation that is a function in each of the following forms. So what we want to do is we want to draw a mapping diagram that is a function and a mapping diagram that's not a function. And we're going to do that for each of the 4 types here. Everybody okay with that? What does the mapping diagram look like? What's that, Kate? Yeah. Yeah, it's similar to this down here. Yep. That's the. Yep. Well, I put it on the review. Okay. So we'll label the first circle as the domain and the second circle as the range. Does it matter what numbers I write in here? No. Within a little bit of reason, what's the one thing that I can't have going on in here? Repeats. So, as long as I can put in whatever numbers I want in here, but I can't have anything repeated. Okay. And now, if I want this to be a function, what do I have to make sure happens? So every x has an arrow coming from it, and it only goes to one y. So 1 can go only to 4, 2 can only go to 4, 3 can only go to 5. That's a function. Sure. Sure. You can just have only one arrow going from a domain, and every domain has to have an arrow coming from it. Okay? Everybody's happy with that? Okay. Let's say we wanted to make something that was not a function now. What would I have to do to make this not a function? Okay. Sure. That would work. That's not a function. And the reason it's not a function is because you have one of the things in the domain being used twice, right? It's going to 2 separate y's. What's the other way that you could do this to make it not a function? You have one of them not going to anything. So if 3 it just doesn't go to anything, also not a function. Everybody's okay with that? Okay. Everybody happy with 1A? Okay. All right. So the next one is a set of ordered pairs. What do I mean by a set of ordered pairs? Something like that. Everybody happy with that? Okay. So what's it going to look like if it is a function? Great. So does anything else matter other than that? No. Does it matter what x values you pick? Does it matter what y values you pick? Just no repeat of the x's. Can the y's repeat? Yes. Do they have to repeat? No. This is a function. What I wrote right here. What would it look like if it wasn't a function? Okay, at least one x value would repeat, so let's say the 1's repeat. and then we can keep everything else the same. But that's enough to say it's not a function. Because we have an x value that repeats. Yep. Everybody okay with that? Okay. I'm going to erase. Is it okay for me to erase? All right, let's do a graph then. I assume we all understand what I mean by a graph there, right? Okay. When I draw a graph of a function or a graph that is a function, what do I need to keep in mind? Great. Does there anything else that matters? No. So, is that a function? No. So we have an issue there, right? Okay. Is that a function? Everybody feel happy about what to do with the graph? This is usually the easiest one for students. Okay. Okay. The last one is the equation. So does anybody remember the equation of something that is a function? Great. So let's pick specific values for m and b, but like, what? You could say f of x instead of y, that's fine. Everybody's okay with that? She said y equals mx plus b. I'm going to pick specific m's and b's so that it's specific, but that's because before it wasn't really an example, but that works. So this is a function. Somebody remember an example of something that's not a function? Yes, sir. A circle. Great. So x squared plus y squared equals r squared. So maybe that'll do. Everybody okay with that? So that was kind of the example that we used over and over again in the notes, was the graph of a circle. Is that an I? That's a 1. Yes, sir. Of course. Anybody with more questions on 1? Yep. So that was parts A, B, C, and D. So for the next 2 through 9, we're asked to determine if it's a function or not, justify our answer, so like some kind of explanation as to why, and then write the domain and range.
Okay, well, number 2 is not a function. Number 2 is not.
Oh wait, number 2 is the equation.
Oh, I'm sorry. I was looking at 3.
I also thought number 2 was the graph.
Well, this was the equation. So
Number 3 is a function.
but number 2 is a function.
So 2 is a function. Well, there's nothing squared in it, right? A circle is x squared plus y squared equals r squared. Well, it says 4x. There's no squared in the exponent on the x, and there's no squared on the exponent for the y. So it could be, but it might not be. In general, if you have an equation, the easiest way to tell, because probably many of us looked at this and weren't sure, And that's fine. What I would do is I would get the y by itself so that you're able to type it into our calculator and look at the picture. Because if I can get a graph out of this, it's easy to tell what's going on, right? So I could subtract 4x from both sides and then divide both sides by 2. And now I'm given something that looks like y equals mx plus b, and I should be sure that this is not, or this is a function because it's the equation of a line, right? Okay. Let's just type it into our calculator just here for fun. You guys all have your calculators figured out?
My brother took mine. I need to put the batteries in my future blade.
Okay. We should make sure that our calculator situation is squared away before our test here, though, okay? Yes, sir. Of course. Everybody happy with looking at the graph here? Okay. So, yes, this is a function. As far as justifications, I want to be clear about this, about like what the expectation is here for a justification. So, Kate, you said it passes a vertical line test. In order to use that justification, I would want you to copy down what you see on your screen and show it like passing a vertical line test if you're going to use that as an explanation, which is a fine explanation. But if you're going to use that and there's not a graph provided, I need you to show me what you graphed in order to use the vertical line test on, which I think is a fair expectation, right? Alternatively, as a justification, you could say this is y equals mx plus b, which is a line, which is a function. Also, perfectly reasonable explanation. Yep, I would accept that for sure. Everybody happy with that? Okay. And then lastly, for C, write the domain and range. So if I'm looking at the graph, which is probably the easiest way to determine the domain and range here, to find the domain, we're talking about the x's. So I'm going to find the leftmost point on this graph. Is there a leftmost point on this graph? No. Why not? Because it's going to the left forever. So my lower bound would be negative infinity. Then I would try to find the rightmost point on the graph. Is there one of those? No. Why not? Also going on forever, so I'd write positive infinity. And I know to put parentheses because the infinities always get parentheses. Yes, Alexa.
So it's like a graph, and like one of the sides is like straight up, if you put positive infinities to the end.
So if one of the ends was going straight up, if it was perfectly vertical, it would no longer be a function. But the pointing up doesn't affect the domain, because the domain is only about the x's. So no, to answer your question. If we're talking about the range, yes. So the range is up and down. So the pointing up is going to do that for the range. Is that okay, Alexis? Or Michael?
So, is the bracket or parenthesis included? I always forget. Parenthesis is included. I mean, bracket is included, right?
Correct.
Okay. Bracket is included. Parenthesis not included.
Correct. Okay, and then let's do the range here. So the range is about which coordinate? The y. So we should find the lowest point on the graph for the y. Is there a lowest point? No. Why not? because it keeps going down forever. So we'll have negative infinity for our lower bound. Then we'll find the highest point on the graph. Is there a highest point? There is not, because it keeps going on forever, so we'd write positive infinity. The domains and ranges for these equation ones are probably the worst ones, because you don't have a picture to look at or specific x and y values to use. My suggestion is, on the equation ones, is to use your calculator to generate a picture and find the domain and range from looking at the picture. Usually makes life much, much easier. Everybody kind of agree with that? Okay. Can I erase? Just so things are getting a little convoluted there. Now let's look at 3. 3 is the graph below. Is this a function? No. Why not? Okay, good. So if you write fails VLT and draw some vertical line that's intersecting at more than once, that's good enough for me for justification. Let's do the domain and range now. So for the domain, I want to locate the leftmost point, which would be like this spot right here. Everybody agree with that? I think that's a -1 right there that it's matching up with. That's okay though. And then I'd find the rightmost point, which looks like it would be here. And that looks like it's matching up with 3. Everybody okay there? Should I use a bracket or parenthesis? Bracket for each of them. Why would I be using brackets here? Yeah, because this is literally the point -1, -3. There is a point with the x-coordinate -1. Similarly, we have the point over here, 3, -3. We literally have a point with the x-coordinate of 3. Is everybody okay with that idea? Okay. Let's do the same thing now for the range. So the lowest point on my graph looks like it would be there, which is, let's see, that's 1, -1, 2, 3, 4, 5. And the highest point on my graph is right here. That looks like 1, -1. Everybody agree with this? So I have -5, -1 for my range. Brackets or parentheses? Brackets, each of these. Again, because we literally have the points on the graph with those y-coordinates on them. Questions about 3 before we move on? Okay. I'm going to erase now. Is that okay? Good. If I look at 4, is this a function? No. Why not? So we'll say, when we say that though, notice that I was very specific and I labeled the 1 as an x, because if I look at this graph, we also have a 1 in the y's that repeat, right? So we should try to be very clear that we're talking about an x-coordinate that's repeating. Specifically, the value x equals 1 repeats. Everybody's okay with that idea? So again, just be a little bit careful on how you're communicating that, because if you just tell me 1 repeats, I don't know if you're talking about a repeated x or repeated y. And while it's clear to you, it's not clear to the reader which one you'd be talking about. Okay? The domain here, notice that this set is discrete, that there's just a finite number of x and y values, right? So we can just list them using our set notation. Notice when I write my lists, I'm not repeating anything. So even though some of those numbers are used more than once, they only appear one time on my list. And that's because the way we define a set is that it contains no repeated elements. We happy here? Okay. Let's look at 5. That's the mapping diagram here. Is 5 a function? What do you think? Is 5 a function? No. Not a function. Good. Why not?
Because I think almost all of them go to, yeah, all of them go to,
Not every
yeah,
X one has one.
So you could just say, for example, x equals 1 goes to 2 places, or has 2 y's. Again, you don't have to, does it matter that all of them go to more than 1 y? No, you just need one instance that happens for it to not be a function. So just pick one of them, even if there's multiple. I mean, you could list them all if you wanted to, but it doesn't make it more right. Okay. The domain, again, how many x's are we talking about here? Just 3 of them, so we can just list them. And similar with the range, there's just 2 of them, so I can just list them. Notice that I'm using the squiggly brackets and not a hard bracket or a parenthesis here. Everybody's okay with that? Okay. Let's move over and look at 6 then. Is 6 a function?
No.
Okay, a lot of people say no. What would be a good way to check? Yeah, we could graph it and try using a vertical line test on this. Great. So if I go to my calculator, is there a way to type in a plus or minus? Good. There is not a way to type in a plus or minus. What we will do is we'll type in 2 separate equations and look at the graph as the graph of one equation. So, Jack, you're exactly right. So we'll do x plus 1 in the first slot and x minus 1 in the second slot. And then if we look at the graph of this, this is one graph rather than 2 graphs, is how we view this. And if you look at that, definitely fails a vertical line test, right? So the graph is a pair of parallel lines, which are definitely fail to be a function all over the place, right? Alternatively, what you could do, if you didn't like that, is you could pick a value for x. Say I pick x equals 0. If I do that and I solve, I get that y is plus or minus 1. So this tells me I have the point 0, 1 and 0, negative 1. That's 1x that goes to 2 separate y's, or that's a repeated x coordinate. All of those would be fine justifications as well if you didn't draw the graph. Is everybody okay with that? As an alternative justification, you did not need to do that and draw the graph. Drawing the graph would have been fine. Or doing this would be fine. Either one is fine. You don't have to do both. Just presenting other options, because there's more than one way to kind of skin that cat. Sierra.
when you got more like into graphs and how to do it on your calculator, I'm not like I had a piece of paper that kind of like walked me through like what to put.
Mhm.
Like
with a transformation.
I think I'm catching something.
Sierra. Okay. Let's do the domain and range then for 6. Easiest to do this by looking at what? The graph. That's correct. So if I look at the graph, is there a leftmost point? Not really, right? Is there a rightmost point? Okay, so there's my domain. Is there a lowest point? No. We're on 6.
Well, on 9 there's the lowest point.
That is true. There is a lowest point on 9. Okay. All right. Is there an uppermost point? No. Everybody's okay with that? May I erase? Okay.
I've never
Let's look at 7. Is this a function? Yes. What would I use as my explanation? We said it was a function. That would be good. You could say no x's repeat. That would be fine. You could plot these points and convince me that it passes a vertical line test. That would be fine. Everybody's okay with that? Alyssa. Yes, of course. All right. And then the domain and range for this. Again, yep. And the range? Correct.
Oh, I mean, you wrote it, but I was like figuring it out.
No, I saw what was happening. Everybody's happy with that one? Okay. Let's look at 8 then. Is this a function?
Oh, yeah. Oh, I bet you that's where I said the answer for what I was talking about.
That 8 is a function. Why is it a function? Each x goes to only one y. You could say that none of the x's are used more than once. You could plot these 3 ordered pairs and show it passes the vertical line test. That would be okay. Everybody's okay with that? So the domain then is just 1, 2, 3, and the range is just, I think that's a 21. Let's go with 9 now. Is this a function? 9. Why would you justify it? Good.
What is the actual BLT mean?
Bacon, lettuce, and tomato.
You're going to do that BLT minus 15?
All right. Okay. Now that you've made us all hungry again after just getting back from lunch, let's do the domain and range then for 9. Is there a leftmost point on this?
No, it's positive negative.
Okay. Let's look at the range. Is there a lowest point on this graph? Yeah. So if I track over, that looks like it's happening at -4. Is there a highest point on this graph?
Yeah.
It's infinity.
So We know that the infinities get parentheses. Let's determine the negative 4. Good. I agree.
It's included.
Alexis?
Both of the lowest points are at the same spot. Did you say like they're both in global minimum?
Yeah. That would be fine. That you could say this has 2 global minimum. Or minima, I guess I would say. To do the grammar correctly. But yeah, good question. Everybody happy on number 2 through 9? Okay.
I mean, number 6 is a little difficult personally.
Right, but
Practice never would have known that. I didn't go over that. I would have
yeah, that's the point of doing them, though, is to, like, here's some tricks. Like, once you knew what the trick was, it was easy, right? It was just, oh, that's how I graph that on my calculator. Once I have the graph, it's not a problem. So, okay. All right. So here, we're asked to write the domain and range, positive, negative, 0, increasing, decreasing constant, and end behavior. Does anybody recognize this? This is the same graph for number 9.
Oh, well, yeah.
I just labeled the points on it.
I mean, I'm pretty sure a lot of graphs look like that, but I don't know.
So we did the domain and range there. So I'm just going to write those in. Everybody happy with the domain and range part of this?
Yes.
Okay. So let's do the positive part.
I know, I just didn't use those parts of the column.
Okay. It doesn't matter that. Wait, why do you have negative 4?
So that's a little.
That's the range.
Never mind.
Miss Lenz? Yes. What's your first name again? McKenna. I had Taylor, I don't know, some years ago, and I kept wanting to call her the wrong name, and I keep having to fight myself.
So when you're writing on the range, does the lowest point have to go first?
Yes. All right. So the positive part, the graph is positive from there to there, from there to there, and then from there to there.
Negative 4, comma, and then just positive 5. Just to kind of like. Oh no. It would be negative 4 to negative 1. And then 1 to.
So this positive part is negative infinity to negative 4. This positive part is negative 1 to positive 1. And this negative part is 5 to positive infinity.
Why did you put negative 4 with
Because if I look at the point where negative 4 is the x-coordinate, that is not above the x-axis. It's on the x-axis, and the definition for positive is the parts of the graph that are above the x-axis. And at negative 4, we're not above, so it should not be with the positives. Okay with that, Sierra?
Yeah, so basically it's on the x-axis, there's going to be a parentheses.
Unless you're talking about the 0 part, yes. So we're negative from here to here and from here to here. So I have negative 4 to negative 1, and then 2 to 5. Those are the parts of the graph that are below. Yeah.
Is it
Oh, thank you. Appreciate that. Everybody okay there? And then my zeros are at -4, -1, 2, and 5. And I listed those because there's just specifically 4 zeros exactly.
So when would it not be?
So if your graph, say, for example, looked like this, here the zeros are some,
Be like domain range.
yeah. Yep.
So why would you curly brackets set up the brackets with like absolute points on the top?
Right. So how many points are there in this little section? Infinitely many. Because it's a connected line segment, right? So I drew this separate picture for Jack who asked, when would it not be a finite set for the zero? So I drew him this picture to give him an example. There were exactly 4 on the problem. That was a hypothetical. Okay? Jack, you feel fine?
Yeah, I just didn't know it.
Yep. Good questions. Okay. All right. So I'm going to erase these marks out of here, and we still have to do increasing, decreasing, constant. So the graph decreases from here to here, and then from here to there. If there's like finitely many of them, yes. Yes, of course. And then we're increasing on those sections. Stop talking, please, guys. So increasing is going from -2.85 to +0.5, and then 3.85 to positive infinity. And then we're decreasing from -infinity up to -2.85, and then again from +0.5 to 3.85. I ran out of space there. Everybody okay there? Okay. The last, is that a question? Okay. That's okay. The last thing we're asked to do is to list the end behavior. So remember, the end behavior is describing the direction the arrows at the end of the graph are pointing. So the left arrow points up, and then we say the right arrow points up. So remember, when we say left and right, we're talking about x's going either positive infinity or negative infinity, and then the up and down is the y either going to positive infinity or negative infinity. Everybody's okay with that? Up and down is y's, left and right is x's. Okay. So 11 is just doing the same thing over again? Yes, Jack? Okay. So the uncomplicated answer is that increasing and decreasing are always going to be all parentheses. Okay. That's the short answer. Okay, good enough. Guess we're out of time here.